right, well, hello everybody, and welcome to the Python for DevOps Bootcamp. I'm your host, Chris Keenan, and we just have a few items to go through before I can hand things over to Noah and he can get started. First and foremost, please make sure that you download or clone the code repository from the course, and you can get that from GitHub. This link was in the email that was sent around, but I can also copy and paste those links into the chat for you. If you need those, just give me a shout. And as well, if you haven't already, please do sign up for a free AWS account at aws.amazon.com. And it's also very helpful if you have a Google account that you can use to access notebooks in Colab. Now, for those of you who may not be able to get into Colab, or maybe there's firewall restrictions or what have you, if you're a Percipio client, we do have a sandbox available on our platform that you can use too. But I think, preferably Colab is the way to go if you can, but I'll show you quickly how to get into that. All right. So as I said, my name's Chris Keenan. Some of you might have seen me before in some of the other boot camps here. I'll be your host and the guy kind of behind the scenes. I'm here to basically help move things along and help you guys and make sure that things are running smooth for Noah as well. I'm a tech and dev content development specialist here at Skillsoft. And of course, your host is Noah Gift. Now, Noah, he's the founder of Pragmatic AI Labs. He's also an ML Ops expert, an ML engineering expert. He's an author and a lecturer at Northwestern, Duke, and Berkeley, and of course, the University of California at Davis. He's also acted as a chief technology officer. And if you want to learn more about Noah or his company, you can always look him up at noahgift.com or paiml.com. Just a quick run through today, the session's running from 11 to 1 p.m. Eastern, and it'll be the same thing for tomorrow too. We do ask that if you have any technical questions that you do throw those into the Q&A, and Noah will be getting to those throughout the session at a couple of excuse me, scheduled times throughout the session. So don't worry about that. The reason that we ask that you use the Q&A is that sometimes the chat can get flying by pretty fast. And if there's a question, it might get missed. But in the Q&A, we can just go through and check them off as they've been answered. So it's a lot easier to manage them that way. The chat you can use to talk with each other. If you have some feedback that you'd like to share that you want everyone to see, please do set your reply to all panelists and attendees. But if it's just something for us, you can just set it to all panelists, okay? Excuse me. And of course, we have a Percipio channel set up for this bootcamp. So it's Python for DevOps. You can grab the syllabus there, supporting assets for the course. So basically the copy of the GitHub files, as well as the replay sessions as they'll be posted. Now we post these to Percipio as well as SharePoint for those of you who may not be a Percipio client. And I know that typically with a campaign like we're running for this one, we do get people coming in that aren't Percipio clients. If you need that SharePoint link, again, I'll be pushing that out in the chat, but if you missed it or what have you, just ping me and I'll give it to you. Also, we do have a survey that we'd love you to take maybe 5 minutes at the end of each day and just let us know what you think. We do value any and all feedback, and we try to use that to improve future sessions, or if we need to be agile about how we're delivering this one, we'll try and make any tweaks if we can. For those of you who might be working on Python or DevOps related content outside class and you need to pick the brain of somebody or you have a few questions, you can also reach out to our mentoring team at Skillsoft mentoring@skillsoft.com. Okay, so I'm just going to very quickly show you how to access the Percipio Bootcamp page as well as the sandbox, and then I'll pass things over to Noah. I know he's got a lot to get through, so just one second. I'll drag my browser screen over. So as I said, we do have a Percipio channel set up for this specific bootcamp. Just search for Python for DevOps Bootcamp and you should find that. Again, you'll just see links for each of the days here. And as we post the replays, they'll show up down near the bottom. You can also grab the resources from the class by using this resources dropdown. So right now we just have the syllabus and the GitHub repository here. You can download those to your local machine. The sandbox is under this practice tab here. And once that loads, of course, it's going to take a moment since we're live. There we go. You can use this to access the Python for DevOps Bootcamp sandbox. And in this sandbox environment is where you can use Jupyter notebooks as well as the bare bones Python editor that's part of the sandbox to work on the code. So once you click on that, it should launch into a new tab, and it just takes a moment or so to load up. Once it does, though, you can hide these instructions on the left-hand side. You don't really need those. Just wait for that to come up here. There we go. Yes, of course, it's running slow. This usually only happens in a live class or for potentially demoing this for a potential client. All right. Okay. Well, that's lagging a little bit now. I'm not going to. Okay, there we go. All right. So yeah, so we have Jupyter notebooks here as well as a terminal window. We already have the examples loaded up here, and you can access them in the file tree on the left, or it's probably a bit cleaner to navigate into these folders by using Jupyter. So you can just expand this, and we'll make that a little bit bigger. You see all the Python for DevOps files in here. You see the Jupyter notebook in here, as well as the README and some requirements and whatnot. So everything that you need is here. But like I said, preferably use use your Google account and use Google Colab. Everything's already it's going to be set up for you in that environment as well. And actually, it looks a little similar to this, but I think that's enough for me on my end. If you have any questions, just ping me in the chat and I'll be more than happy to give you a hand, okay? So with that being said, without any further delay, Noah, I'm going to pass things over to you.
All right. Yeah. Thank you, Chris. Yeah. So as Chris mentioned, a lot of my current work is on teaching. I spent a lot of my career doing stuff. So building solutions, managing engineering teams. And then probably the last several years now, I've been really focused on how to create material that will really teach people skills that can lead to a better job outcome, upgrade their skills, or maybe help somebody that's entering the workforce. And so this is very vocational focused training. And in particular, I think it's a really exciting time to be studying DevOps. And in particular, I think machine learning is really benefiting from a lot of the history of DevOps. And I would really call all this just a form of automation. And that's really what we're studying. We're using the word DevOps, but we're essentially automating both software and also automating machine learning. So let me go ahead and share my screen here. And I'm going to give you just an overview of the stuff that we're going to cover. And here we go. Yeah, so in a nutshell here, I think hopefully everybody can see that we're going to start through over the course of the next couple of days, and first just get into a brief overview of Python, just enough. Even if you don't have experience with Python, I think we can give you enough of a bootstrap so that some of the other lessons are easier to assimilate. And then let's say 45 to 55 minutes or so, we'll take a quick break and answer any questions that you have, so that you're familiar with, maybe something you're stuck on. And then for tomorrow, we'll cover the second part, which is developing with a command line, and then also continuous integration and delivery, which is really probably the foundational component to implementing DevOps in an organization. So in part one here, what are we going to talk about? So we're going to really get into, what is DevOps? Why do we actually care about it? Then we'll get into what I call minimal Python. So procedural statements, lists, dictionaries, writing a dictionary with immutable key, functions. And this is really a subset of what's necessary to be successful in Python. So before we start here, one just more of a open-ended question is that what is everybody's experience with DevOps? Would you say you're not familiar at all, or you're somewhat familiar or very familiar? And so maybe that's something you could hold in the back of your mind here for when we do Q&A, and see how we can help you with getting more experience with DevOps if you don't have any familiarity with it, or if you're already familiar with it, what are some things that we can cover over the next few hours today and then next week to kind of bootstrap that. So before we get into the actual code, I just wanted to cover just theoretically, what is DevOps, because I think there's some misconceptions about it, and a lot of times in technology companies, you get these buzzwords like Agile, DevOps is another one, and it's like, wait, what is this? Why do I even care about it? And to me, it's really about just one thing, which is this concept of a feedback loop. And when you build things using this feedback loop, where you're able to constantly improve what it is you're doing, and this is a word in Japanese called Kaizen, which is this concept of continually improving what you do on a daily basis. That's really what DevOps is. And so how do you do DevOps? Typically, the center of what happens in DevOps is the build system. And throughout my career, I actually got a pretty good reputation in coming into companies, and really all I did was set up the build server. And a lot of times the reason why there's problems with, for example, speed in an organization, or there's problems with quality, or there's problems with maybe performance, there really can come back down to this root cause analysis of, does your organization have a feedback loop, and is the feedback loop continually getting better? And hopefully there's actually a very short time range here. And so really almost hourly would be the best way to have a feedback loop. So let's just say 1 hour to maybe 1 day would be the dream feedback loop in an organization. So what this means is that you have the ability to automatically deploy your software to production. You automatically test your software. You are getting feedback from customers. There's a bug, you're able to fix it. And so you're thinking of software really, instead of how many organizations think about software, they think of it as a building, right? Where they're going through and they're building, concrete. That's, in my opinion, the wrong way to think about it, because a building is stable, right? So this is fixed. But in software, you're really growing a plant. And when you're growing a plant has a feedback loop. A plant needs the sun, it needs water, it needs the correct nutrients. And this is very similar in terms of software, is if you have this mentality of that there is no done with software, it's just a constant process of improvement, then that really can have a massive organizational change that can improve these problems that an organization has had with, we can't get anything done in time, it takes too long, or our software is always poor quality, or we're having stability issues with performance or scalability. Really, it's this is the way to solve those problems, is if you have an hourly, daily, weekly feedback loop. Maybe you have to start with a weekly feedback loop, and you're just constantly looking for improvement, and you think of what you're building as organic, right? So it's a plant versus a building. Then I think this is the mindset that will make your organization successful with DevOps. So that's the really quick, high-level tour of what my opinion is of DevOps based on real-world experience in many companies. So let's dive into this particular repo here. And as mentioned before, there's a Jupyter notebook here that's in code format. And what's nice about this is that if you click on it, it's a 100% reproducible environment. So what this means is that whatever I'm doing, you can do the exact same thing. And just in general, that's a good idea for DevOps, not just in teaching things in a webinar, but in terms of DevOps having a reproducible environment where every single person can replicate what you're doing is, I think, a really big win in terms of building software systems. And that's actually a very DevOps type principle. And you can see here, there's a whole table of contents if you want to look down here. And so what I'm going to do is I'm going to connect to this runtime. And as I mentioned potentially earlier, that a lot of these ideas that we're going to cover over the next several days or a couple days are in this book, O'Reilly Python for DevOps, which I co-authored with probably 100 years of experience of combined authors here. So we talked about this. What is DevOps? My opinion is that it is this feedback loop. That's really the definition. And if you look at it, you can see DevOps actually all over the world in not just software. You can see it in machine learning. You can see it in education. You can see it. It's really this concept of continuous improvement. And in particular, though, the way AWS defines these practices is it's continuous integration, continuous delivery, microservices, monitoring and logging, communication and collaboration. So this would be the tactical. We're really talking about the strategy of DevOps, but the tactical stuff is that continuous integration, which we'll do tomorrow, is critical because of the fact that
Hey,
with
Noah,
yeah,
sorry to
yes.
interrupt. Are you able to share just that application window? Or right now we're seeing like your whole screen and
Okay.
like with everything on it, and it's showing up
Okay.
quite small. So
Oh yeah. Thank you. So let's go back here. Yeah, that's interesting. But let's go to here. And let's go. There we go. Yeah. Sorry, I have a
oh, no
huge monitor.
worries.
There we
Perfect.
go. Okay. So with DevOps here, these are the tactical issues, right? It's continuous integration, continuous delivery, microservices, monitoring and logging, communication and collaboration. And in particular, why are these tactical issues so important? Well, the main issue about why they're so important is that these are specific things that you can do, almost like a checklist of how do I make things better, right? If that's the goal, is to continuously make things better, one of the ways to do it is go through this checklist. Is my code tested automatically? Am I able to deliver software automatically to production? And then this is kind of a stealth one here that is really important is, can I build really small things that are single purpose? And the reason for this is that by simplifying the complexity of your environment, you make it easier to debug things, easier to go fast. And then this is another one I think that's really easy to dismiss, is that a lot of maybe organizations are not thinking about monitoring and logging enough. And really, this is something that the world has embraced now, is data science. I teach in multiple data science programs, and really monitoring and logging is data science, but for machines. And if you don't know what's happening and you don't have the data, how could you possibly debug things in production? Just like hopefully people are making decisions with data, not just their intuition. Same things with building systems and monitoring systems as you're looking at data. And then finally, the communication and collaboration. I think this is really about the feedback loop again, is how quickly can you move? Are you doing things in an efficient, maybe asynchronous way versus a synchronous way? I think the world over the last year has started to see this as well, that there's actually, from a computer science perspective, there's a lot of benefit to creating these asynchronous workflows. That's how web development works. That's how a lot of games work, is you have asynchronous networking, but you can do the same thing as a human. You can have asynchronous communication. And so I would encourage you, if you have a chance, to take a look at this DevOps best practices and kind of dive into those. Okay, so enough with the theory here. Let's dive into some of the actual code here. And in particular, with IPython, Jupyter, Colab, executable, one neat little trick that you can do that I found that's kind of fun is that you can put this exclamation point inside of a code cell, and you can just type in bits of code, and that can really be helpful in terms of scripting things. And I think if you think of DevOps as a form of automation, scripting then really does play a critical role. And if we look at this, one of the nice things about using IPython, or in this case, it's Colab, which has the IPython framework inside, is that it gives you this special data structure called an S-list. And what an S-list does is it allows you to do complicated operations with a built-in method that appears on that variable. So notice here that when I assign the output to this exclamation point ls-l, we're able to get the output here. And then I can actually search through that using fancy Python tools. So that's just one little trick to be aware of that I think many people are not familiar with. There's also fields as well that you can do high-level scripting by mixing the bash and the Python mechanisms together. So one other thing here that we'll look into is that Jupyter really has a few different flavors. And in particular, there's Jupyter Hub, there's Colab. These are all essentially variants of the same thing. Kaggle is basically running Jupyter. SageMaker from AWS, which is their machine learning platform, runs Jupyter. Microsoft ML Studio runs Jupyter. We're doing Jupyter right now with Colab. It really is a dominant platform for doing many things in terms of automation. And I would say it's probably one of the best ways to bootstrap yourself with Python because of the fact that it's a protected environment, especially if you run a hosted version of Jupyter, where a lot of the problems that you'll encounter with Python go away because it's a maintained environment. And that's really a pattern that I would encourage with DevOps is, if possible, use a cloud hosted environment that manages all the packages for you, because it solves many problems that really are not that fun to solve on your own, like installing packages and maintaining packages. And so you can see here, there's a whole bunch of different versions of this. Every cloud platform potentially has, access to something with Jupyter. In particular as well, Colab Notebook, the one we're using, has a few things that are pretty unique here. And one of them that's kind of unique is if I go to runtime, is you can actually change the runtime and get access to a GPU, which really is pretty awesome in terms of being able to build solutions that use, let's say, the CUDA SDK, which is the NVIDIA SDK in Python. There's a lot of benefits, and also you can in this case, if you buy the Pro version, you can get higher RAM. But every cloud platform, not just Google, has some variant of this. Now, the other thing that I'll kind of go down here and talk about is that with Colab or Jupyter Notebook, one of the things that you can use are these magic commands. And this a lot of times is a great way to test out a snippet of code. And notice if I put in %timeit, what it does is it runs this piece of code several times, and then I can look at the intermediate result here and see, essentially how long it takes. Another thing you can do is you can go to alias. And so notice in this situation here that, let's say I needed to do something fancy to a directory, very commonly, I don't know, look at the log files or, zip up a file or something like this. I could create an alias inside of Jupyter Notebook here. And then every time I need to run it again, I just run that alias, just like a shell alias. And that really can be helpful in terms of, automation. You want to read a little bit more, you can go to the interactive version of IPython and look at some of the magic commands there. Another one that's kind of a neat one as well is who. And so what I use this a lot to kind of figure out what's happening in my memory. So if we go through here and we run this first variable, and then I go through and I type in who, what it does is it shows you what's been loaded into memory. So this is really helpful if you're dealing with maybe lots of variables that are similar, or you've rerun something multiple times, and then you'll see that, oh, okay, I have a variable called too many decimals. Okay, what is that? And then you can take a look at it and inspect it. So it's a nice little tool that I think is good to be aware of. Another one that's helpful that I use sometimes if I'm really building something quickly is that you can actually write out a script inside of Jupyter Notebook by using this command write file. And really, this is kind of a quick and dirty way to build, use Jupyter as like an IDE. Is notice if I do %% write file, I can create this file called magic stuff. And this is just really kind of a toy script here that does some things with pandas. But if I run this, it doesn't run the code. It just writes this out to a file called magic stuff. And in fact, if I go here to this files location, we should be able to see that file listed right here. So I think if I just do this, refresh, it should show up here. I don't know why it's not showing up, but basically it's locally on your file system at this point. There we go. You can see it right there. So you could download it if you wanted to. Now, if I cat this, just if I scroll down here and I cat this file, give this a second here. Maybe just do there we go. So if I cat this file, let's go through here, that you can see that's actually what the output was. And then if I want to run it, I can do the the exclamation point and actually call the Python interpreter itself and then execute the code. So it's a neat little hack, I think, that can be helpful if you want to just really quickly use Jupyter Notebook as like a feedback loop that essentially allows you to run commands by scripts that you wrote right inside of the Jupyter Notebook. Now, the other thing you can do as well is you can install things, right? So you can run code and do pip install inside of Notebook, and then if you wanted to, you could actually lint this code as well. So there's a lot of neat little tricks that you can do by essentially using this as an IDE. Now, another trick that I'll show you here is that bash itself is kind of an interesting command that you can mix in. So again, if you're from a DevOps perspective, let's say that you've got some existing bash scripts that are really important to your organization, and maybe they're monitoring scripts or something like this. Well, what you could do is you could actually invoke that without having to write a bunch of boilerplate code that calls the bash script and does all these things. You could just put %% bash, put in whatever that bash script you want, and you could actually make this almost like a monitoring tool where you could run through a bunch of different commands, and you could even label those commands like this. So I think that's just another really helpful thing to be aware of in terms of what you can do with Jupyter Notebook. And then a couple last things here that I'll mention that are unique to Jupyter is that with Python 2, that if you remember, if you've been around Python for a bit, that it used to be that you could print with a space here because print wasn't a function, and they changed print to be a function. And in this case, you can see I can run Python 2 itself. So this does come in handy, again, if you had older code and you wanted to integrate it into maybe like a playbook that does debugging for your production system, and you don't want to rewrite it yet. You could kind of put this inside of there. So this Jupyter technology, I think, is really critical in terms of your ability to do a lot of fun stuff. And I'll kind of skip through some of these. You can play through some of those on your own. But generally, the main takeaway here is that it's a really powerful mechanism to kind of explore ideas. So let's skip down to this next section here, which is just talking about the introductory concepts now. So I briefly talked about this, that what I feel like is a problem for people first getting started with Python is that, and let me just actually sketch this because I think it's important enough to talk about, is why are there, why are there problems with learning Python or using Python or adopting Python? And I would define it almost like there's a road, and then we'll just call this lava on both sides of the road, and basically you don't want to step in the lava, right? It's very bad. So you're kind of on this road here, you're walking, and to the left would be advanced computer science, and I think one of we'll just call it advanced CS. And one of the problems is that a lot of times you'll hear things like OO, like object-oriented programming. You'll hear about concurrency as well. And you'll also hear about things like, algorithms. And these are obviously very important. Many organizations do things with all of these different topics, but they really have almost nothing to do with actually building DevOps solutions. You can basically take away 80% of the Python language and just get rid of it, right? Because this is all advanced computer science stuff that it's easy to think that that's being an expert in Python, is that you have to know those things, but really you don't for DevOps. So that's one lava pit that you don't want to walk into. And then the second lava pit would be your environment. And if you can avoid both of these problems, you can really run circles around other organizations, because you're not getting trapped in these places that they're just inherently complex. And on both sides, all of this advanced object-oriented programming, concurrency, algorithms, that's complex. And then in the environment, it's basically installing software, installing packages, all those kinds of things. If you can basically not do that, and use in the case of AWS, use maybe their Cloud9 environment, or with Google, use things like Colab, that you're avoiding these things that are really traps that suck up your time. And then you can say, this is the road to productivity, is this middle path. And I wish someone told me this 20 years ago, that this is like the golden path is avoid complexity on both sides and focus on just a small subset of Python, which is what I'm covering right here, which is procedural statements, knowing about data structures and functions. That's really the minimalistic Python that you need. And so let's just recap some of these topics, or even go over them for the first time. With Python, you could be productive for years and years by just putting a statement together. And you see this a lot in data science, is that really it's just a line of code is doing something. It's almost like using a spreadsheet in Excel. And so here we go as well. We have create variable. I can create a variable. And this, again, is just a statement. So a statement is just telling Python to do something for me. And if we scroll down here, I can put multiple statements, right? So I can take a variable here, which is an attack called a kimura, a second attack, arm triangle. And I can say, in Brazilian Jiu-Jitsu, a common attack is attack 1. Another common attack is attack 2, right? And it's just a series of commands that I'm telling Python to do. It's very similar to telling a dog, hey, come here, here's a treat. Or, telling your kid, clean up this. You're just writing a line of instruction to a program, and it does what you tell it to do. And you probably the most clear example of this is treating Python like a calculator. So if you look at Python here and you see, for example, addition, right? That's a statement. It says 1 + 1, and you're already programming. If you're using a calculator, you may not have known it yet, but you're telling a calculator to do a statement. You can also do similar things with a phrase, right? You can say arm, bar, for more. You can just put a bunch of strings together and just concatenate them together, and that's also a statement. Now these are obviously very simple statements, and so more typically in a real program, you have something that's a complex statement, which is just a bunch of commands together. So this in particular is called a list. And this list is really a way of collecting things so that you can do something with them. And in this case, I put belts, right? In martial arts, there's white belt, blue belt, purple belt, brown belt, black belt. And so what I do is I loop through each one of these things. So I say for belt in belts, this is the syntax to kind of walk through each one of these things. I say, if the word black appears, then run this. This is the belt I want to be. Otherwise, print this other statement. And you see, if you run this, what happens is that it goes through the first thing in the list, and it puts, oh, this is not the one I want to be. There you go, blue. It goes purple. And then at the end, it finally matches that last string here. And it says, oh, okay, let's run this statement. And that's really the essence of statement-oriented programming in any language, but in Python in particular. And I would encourage people to not be afraid of this style, especially for things like DevOps, because there's a lot of value in simple statements. Now, you can put those into a function and then it gets even more valuable, but this is definitely an acceptable way to write code. Now, another thing that comes up a lot in DevOps is dealing with strings. It also comes up with data science as well. And one thing to be aware of in Python is that it already has almost everything you would ever need to do with a string already written for you. And so this is also kind of a takeaway, is that if I make a string in Python, and here's a string here, and I say percent here, is that I can do all these things. I can split the string, I can uppercase it, I can title it, I can count it. So we can just kind of walk through some of these things. And that's really the power as well with Python, is that not only just the statement, but just a variable itself has all of these powerful methods built on top of them. And so that's another lesson with Python is how can you do almost nothing, because probably somebody already wrote a library that does it for you. And you can see here that I can do all these really amazing things with a string. I can swap the case, I can do, and if you want to play around with finding out more of what you can do with a string, what you can do is, if we go and add a cell here, I'm going to click on this to add code cell. One of the things that you can do is actually is use this dot notation. So if I say this, I say my string, and I say dot, it'll populate this list that will show all the different things that I can do. And in fact, I could just look at one of them, like, I don't know, is decimal, right? And how do I know what this does? Well, if I do a shift question mark, this is only a feature of Jupyter Notebook, and then I do shift return, what it'll do is it'll pop up the doc string and it'll tell me, oh, look, this is what this is. It says it returns true if the string is a decimal, false otherwise. So this is also a neat little trick to know, is that everything in Python has this capability, is that you can do first a dot notation, right? And it'll auto-complete it. And then second, you can actually go through and put a question mark and then get the information about it. So it's a great way to kind of play around with something in Python to get more familiar with it. So let's kind of scroll down here a little bit here and see some other things that we can do with strings. Let's give this thing a second to kind of come back here. Okay, so the again, you can see all the different methods that are available on a string. But if I want to actually start to kind of build things out here, this is typically what you would do to process a string. A lot of times, here's a word, Brazilian Jiu-Jitsu. If I want to split that, I would just put that into a list. And then once it's into a list, I can actually find the length of it and then start to do, other operations on it, like, maybe put that into a column, or, and also you can split though with a hyphen. That's another kind of important thing to know, is anything you substitute, it could be comma, it could be space, it could be whatever. Again, all the work is pretty much done for you because you're using these really powerful libraries. Again, this is an example, I want to capitalize it, Brazilian Jiu-Jitsu, it capitalizes just the first string. You also can slice with strings as well. So in this case, this is a basic string again, just that phrase. And I can actually say, I want to get just the last letter right here, and I want to pull that off. But what if I want to get maybe the first 17 characters? I can actually go ahead and say, I want to skip the first two, and then I want to grab the 17 characters after that. So it's very flexible about the kind of things you can do. And notice if you do length here, which is a built-in function, you can find out that this only gave me 17. This gave me the whole 19 characters in that string. And you also can go from backwards to front as well. So in this case, we know that it's 19 long. And in this case, I can start from here. I can count all the way back and then just not print out that first string here. So there's a lot of good things you can do with slicing strings that's helpful. We talked about this a little bit earlier, but you can also concatenate strings, right? And this is something that you'll see. I think this used to be really popular in other languages like PHP. I would when I wrote PHP, I actually would do this, which is kind of naughty because it's not very efficient. But you can basically loop through and like make a bigger string here. And then the world changed a little bit, and a lot of people started saying, well, we should use this C style formatting. And the way this works is you put a percent here, you do a %s, and then you have the word that substitutes in. And this is okay, but the problem is it's really easy to forget to put the % here or % here. And you're just constantly getting errors by using the style. So the new way in Python that I almost exclusively use now is this thing called an F string. And it's actually got better performance, and it's a lot more intuitive, and it's a lot less prone to errors. And so if we look at this F string here, look at this. I can say I love practicing my favorite martial art, Brazilian Jiu-Jitsu 1, 2, 3. And all I do is I put in these parentheses around it, which is a variable inside. And then I put an F there and it prints it out. So it's really intuitive. I also could do the same thing by using triple quotes. People use triple quotes in Python to build a longer phrase. Let's say you were scraping something from a website, you would put into a triple quote so you can do wrapping. Now notice that it puts this annoying, wrap, line in there. So you can actually replace that, the line break. And if you again use the power of strings, I could go through here and I could say, I want to strip that out. Every time I find this line break, I want to replace it with an empty space. There you go. And then you can replace it with an empty space. So just with almost no code, essentially like, the inherent nature of Python, you can do very powerful things with strings, especially if you use F strings. So I think that's the big takeaway. Use F strings and life gets very pleasant with Python. We kind of talked about this before as well, is with numbers, is that in particular, you can add and subtract numbers. You can also build word problems out. Like here's an example of building a body fat percentage calculator. Let's say we were building a web service, a microservice, right, which is a DevOps principle. You could easily turn this into a microservice where you calculate somebody's percentage from a scale or something like that. And then this is the weight, and it says, okay, here's what your body fat is. In fact, this might even be very similar to code that's on a scale you have. And what's nice about this is that it does work with decimals. And with, in particular, this is a nice style to be aware of, is that if you say from decimal, import decimal, get context, you can set the precision to be whatever you want. So here I say 1 divided by 3, which is a repeating decimal. I can set the precision to be anything I want, and it'll show me, however many repeating decimals that I want. And this is a really great way to deal with fractions. Also, Python has the ability to do exponents as well. And so with exponents, a couple different ways you can do it. You can import the math library and do math.power 2 to the 4, or you can actually use this built-in method here, which is gives you the ability to do exponents by using the asterisk syntax. Regular multiplication is just 1 asterisk. So again, this is a great way to familiarize yourself with Python if you're not using it on a regular basis is use especially things like Colab Notebook, use it as a calculator and just start to get familiar with it by exercising Python as a calculator. Here, if we want to convert between different numerical types here, this is a neat little trick that I do a lot, is that I'll just put the word type here, and I'll capture what the type is so that I see what's happening, because Python uses something called duck typing, which is, if it looks like a duck, it quacks like a duck, it's probably a duck. So there isn't an implicit typing system like Java or C#. So you either have to kind of guess that it's a certain thing. Like in this case, Python will guess for us and says, oh, you're an integer. But because we use this type command, we can print out what the type is. And so this can be helpful for debugging. Notice in this case, I explicitly call this a float, which makes it 100.0. But if I put in 100.20, that it knows that that's a float. So mostly Python will kind of do the right thing for a lot of different scenarios. You can do the same thing with classes as well. Like if you build a class in Python, which is one of the things I said is not really necessary for DevOps. You could also detect it by looking at the type of it and noticing that it's got this signature. You can also round numbers as well. This comes up a lot in monitoring, right? So if I put in here and I want to round something, look, I can round this to 6 digits. But also there's multiple libraries in Python that do the same thing. So that's probably one of the other things that's a little bit confusing about Python. And this starts to get into the environment, is that there's dialects of Python. There's regular Python, there's NumPy Python, and there's Pandas Python, and there's even framework Pythons. If possible, the more you can stick to the basics, I think, the less you'll be confused initially, which is the standard library. But in this particular scenario, look, I do 3 different kinds of rounding, and you would think maybe like some of these scientific libraries would be the fastest. But if I do a benchmark of it, what's interesting is that, and we can benchmark it using that time it command, is that we can see that in fact, the built-in Python library is actually the quickest because it doesn't have the overhead that NumPy has or Pandas has, even though they're high performance libraries. And so that's another good thing to be aware of, is that if you're unsure, is to do a benchmark of your code to kind of go through and make sure that you're able to get everything working. So that's essentially the statements. The next thing that I'll briefly talk about here is, before we take a break for questions, is essentially lists and dictionaries. And really the way I would think about these is that this is an analogy that I like to use, is that imagine that you're at the grocery store, and maybe people haven't gone as much lately, but if you think about a grocery store, there's really 3 core ways that you can get stuff out of the grocery store, right? So you have the checkout here, and well, there's method 1, which I use sometimes, is you kind of walk in and you're a person, and then you just literally carry like some water, and then that's okay, but that's basically not really efficient in terms of the bulk. So what is this like? Well, this is like a variable in Python, right? So I can just assign something to a variable. So I can say var equals 1, and that's one way to kind of store data in Python. The second way that you can carry things is you can actually get a basket or a bag, right? So basically you hold this, you kind of hold this basket here, I don't know, we'll make the person hold this basket, and you can put a lot of stuff in there, right? You can just kind of have a collection. I would say this is a lot like a list in Python, where you can put in, tomatoes and salad and, water and whatever it is you're getting, and you can put them into there. And with Python, same thing. You can just put a list here together, and you can say like an apple, a pear, whatever it is you're trying to put into your basket. And that's the way I think you should consider the different ways to store data, is think of it as a container, And then there's a third way in a grocery store, right, is you can get this big cart, and the cart carries a lot of stuff and does, it can go, if you have kids, you can put your kid in the cart and you can go fast, so a cart to me is a lot like a dictionary, and then a dictionary basically can store a lot more stuff and retrieve things very quickly, and it has a key and it has a value inside of it. And with this key, the big takeaway with this is that it has to be unique. So that's just more of just like a conceptual overview of that there are different ways to go to the grocery store and get things purchased, and there's pros and cons to each approach. It's just, and the same thing with programming languages, there's these different data structures, and so that's why you'll see somebody use one approach over another. In particular with Python, you can use variables, which we just went through. There's lists and dictionaries. There's other data structures, but in particular, I would say, again, a minimalistic Python here is that I would focus on these two things. And in particular, if you could only even focus on one, I think a dictionary is probably the way to go, because it has such great performance. And the reason why it has such great performance is that it's designed to be fast for doing lookups. And so what this means is that if I look something up by the key, and I say, let's say I have a dictionary with 10,000 items in it, and I say, does this name appear? Like, does the word pear appear in the dictionary? It will be O to the one lookup performance. What that means is that it will always be the same speed no matter how many things are in the dictionary. So this gives it really, really good performance. And so it's a generally useful thing. The only thing you can't do is something like this, which is if you comment this out here, notice that what it'll say is it'll say you can't do this. It says unhashable type list. So with a dictionary, the key cannot be something that's mutable. So you can't change the dictionary, midstream here. And so that's really the only core thing that you have to be aware of. So here we go. Here's a dictionary that I do by hand. Here's the key, here's the value, here's the key, here's the value, here's the key, here's the value. And so these are different types of submissions in Brazilian Jiu-Jitsu. The armbar, which Ronda Rousey made very famous, that's an attack on the upper body, right? An arm triangle is attack on upper body, heel hook, lower body, knee bar, lower body. So if I wanted to build this out into something, I could start to build things with this. There's another way of defining this as well, which is the lower body. I'm sorry, with a built-in dictionary. And notice I say upper body, lower body. But in particular, what most people do is probably use this style, which is you build it like this, and then in order to kind of pull things out, one way to do that is to use something called dot items. And so it pulls out the key and it pulls out the value. And I would say for submission and the body part in submission dot items, go through here and print out, each one of these lines here. So you can see how you could kind of, maybe this is a form letter, or it's a customer database list, or whatever. You can build these really complex systems by using, again, that container that holds a key and it holds a value. You can also filter with a dictionary as well. And you can go through and basically throw out, if you want, part of it by using this underscore here. And I could only print out, let's say, the values, not the keys. And then you can also look for a certain item as well. So we knew that there was 4 attacks, 2 are upper body, 2 are lower body. And I could go through here and I could say, look, let's go through this and only print out the lower body attacks, right? So it's a very flexible system if you use a loop to accomplish almost everything you would ever want to accomplish in Python. You can do with statements and dictionary. You also can find the keys here. If I want to look at keys, you can find the values if I want to look at values. And then, as I mentioned before, the performance is really good for doing things like looking up a membership here, and you can actually time it to take a look at it. So I think we can basically get through the lists and then go to questions here, which that'll be a great stopping point. So in this case, in terms of Python lists, again, think of it as like a container. You're at the grocery store, you're going to put stuff in your bag. Same thing. You just collect things inside of here so that you can do things with it later. And you can also define it a slightly different way if you want. But again, I think most people probably define lists this way. You just put it into this container with these square brackets. And in particular, one fancy thing that you'll see every once in a while is something called a list comprehension. And why do people use this is it's essentially like an inverted for loop where you write it backwards first. And the reason people write this is that the underlying code is in optimized C. And so if you did need to loop over something really quickly, you can actually get C level performance by using a list comprehension. So that's just a neat thing to know about, is that list comprehension syntax. A lot of the times, though, people will just go through and do on a list. Again, imagine you're at the grocery store, you put all this fruit into your bag or your cart that you're carrying, your basket, I'm sorry. You go up to the counter, you pull out the apple, you pull out the pear, same concept. You go through and you loop things from the list, you take one thing out and you do something with it. In this case, we can see that I could actually even look for a certain phrase as I'm looking through the basket, right? Let's say I'm going home. Let's say I got my groceries in a bag and I'm coming home from, the grocery store. And let's say you have kids in your house and they're looking for candy, right? They would do the same thing. They would look through each one, go through and look, oh, candy, there we go. That's the one I want. I'm going to grab this. It's kind of the same concept as you can look for certain things and kind of discard everything else by doing this matching here. You can also slice like you can do with the strings as well. So if you do the same kind of a style, like go from the back, go from the front, look, you can see first position, last position, first three positions. And this is also a pretty common way to pull things out of a list. You can also do fancy stuff as well, which in this case, I have a list that has several lists inside. And so I can go like basically do a rotation of the list and rotate it into a slightly different direction. And notice how this was, the dominant, top mount, back mount, side control, neutral, open guard, full guard, standing. These are different positions in Brazilian Jiu-Jitsu. I could go like this and I could rotate it so it's more columnar versus horizontal. And so I can do that with the zip operation. So there's some neat little things that you can do with lists as well. And then that's probably a good spot. We can, maybe skip the sets, but all a set does basically is go through and cover making things unique. So let's take some questions here and or a break based on where we're at here. So let's see here. There's a question here that says, I'm new to Python. That's good. Are those double underscores round name or single underscores? So they're double underscores around. That's a common thing in Python, is that I guess I can answer live here. Yeah. So basically, a lot of things in Python, and I could probably make this into a new notebook here just for a second, just as like a scratch pad, is that you'll see this a lot. Is you'll see like this. And this is just a style that Python uses, which means that Python is doing something fancy with that. And so anytime you see that, it's a way of saying it's probably some internal part of Python that probably you don't need to care about too much. And then another question here is, how is a chart comparable to a dictionary? A cart doesn't organize data, and you're implying that there's an upper limit to the amount of data a list can hold, a dictionary can. Fair point. I would say that the core idea, maybe, whether you like that analogy or not, is that that basically you have to hold your data somewhere when you're working with things in Python. And so you're either going to put it into a variable, you're going to put it into a list, or you're going to put it into a dictionary. Those are mostly the common forms. Now, there are lots of other ways to store your data. as well. And in particular, this kind of gets into a slightly more complex DevOps topic, but basically there's the Python language itself, and then there's also databases. And so, typically you're not going to store 1 million records in Python permanently, because where is it going to get persisted to, right? Like, how would you even do that temporarily while you're using a dictionary, for example, or a list? Sure, that's a decent place for it. Or pandas. A lot of people use pandas to store those kind of things. But eventually, if you want persistence, you want to actually store the data and operate on it, then you essentially have a very crude way to split this up would be, you would have small data and you would have big data. And so with small data, you might use something like a relational database, for example, right? And a lot of people have been using relational databases. In fact, they've been using them since 1970. That's when the first paper came out on so it's been well established. That's a useful tool. In fact, SQLite is a really good example of a small data tool, right? And in terms of big data, that this is really some of the stuff that's happening in terms of machine learning, or in terms of data ops, or big data, and those tools can be things like Spark. And so Spark actually is a cluster of machines that can deal with giant data frames that maybe the data is 1 petabyte of data, for example. So really, this is more of like a internal kind of ephemeral, I would say, internal slash ephemeral stuff, and all of those things. Again, I would say in Python, it's just a list, a dictionary, and a variable are pretty much all you need. That would be if we're strictly thinking about things from a minimalistic standpoint. But then when you get into this larger section here, which is, okay, what do I do with persisting the data? Then the crudest possible way to divide it up would be small data databases and big data databases. And the small data databases could be things like SQLite, or like MySQL or Postgres. The big data tools could be things like Spark. There's also things like Snowflake as well, like these big data systems or Athena from AWS, which is another big data management system. So that's my view of the world. Okay, so another question here is what is the advantage of Python compared to R or C or Java or any comparable language? Yeah, that's a good question. So I would say that I do have opinions on this. That let's say Python versus other languages. I've used all those languages. So we've got Python. Why would you use it? And then you've got languages like C, Java, Go, Swift, and so really one of the advantages or the differences here is that in some case it's the only game in town. So if you want to do iOS development, well, guess what? You're going to use Swift. I mean, there's also C#. It mostly, especially if you want to hire developers, you could use C# to do iOS development, but in general, if you want to have a wide pool of people to hire, that's it. There's the only game in town, right? So it's essentially like the only choice. That's one reason. There's other reasons you would use a language like Swift. And then if you look at a language like Java, for example, or C# or Go, which I think all are kind of playing the same space, why would you use this? Well, if you want to build scalable systems, this is really the language to do it in. If you look at most cloud-based systems, they're heavily used Java, C#, Go, even C++. These are all really scalable systems because they have very fast performance because they're closer to the machine. And also they have had lots of years of experience. Right? There's really experienced Java developers who have got 20 plus years experience building scalable systems. And so this I would call essentially like a a high performance software engineer would be building things using these languages. But if you're building solutions on top of those languages, that's where really Python comes in. So Glue, right, is where it really shines, like kind of automating systems that use all those languages using cloud architecture itself. So building solutions in the cloud. So what's nice about Python is that basically, I don't know, I screwed that up, but cloud architecting, basically you don't have to write the high performance system that scales to 1 million users because it did it itself with the cloud provider built, let's say in the case of Amazon, they built something like SQS. SQS can handle infinite scale. And so you can put an infinite amount of messages inside of it. Back behind the scenes, I believe it's probably running Java. It's got some really complex enterprise architecture that scales infinitely. But as a Python developer, you just say, oh, I'm going to put some stuff inside of here, and Python can talk to SQS and benefit from it. So really it's kind of wrapping these other languages. And then also I think for automation, it really is a key language because there's so many libraries that are available for it. So libraries, and then also the speed of development. So that's really the correct way to use Python is to let other languages or other architectures and other cloud providers do all the heavy lifting, and you focus on things that only take a few lines of code. And again, like microservices, scripting, automation. And if you do that, in my opinion, you'll be really happy with Python. If you're going to build, a queuing system that needs to scale to 1 billion messages, per day, I would not use Python. I wouldn't start from scratch and build it in Python. I'd build it in another language, like one of those other languages, and then I would use it from Python and interact with it from Python. Okay, next good question here, which is, okay, as you mentioned that advanced CS concepts aren't needed by DevOps engineers. However, I've seen some companies that practically want DevOps engineers to know data structures and algorithms. Is your opinion a general consensus on DevOps, or is it better to study advanced stuff anyway? Just being curious. Yeah, that's a great question. So I think that this is an interesting topic, which is like, what are the skills you need to actually be successful in DevOps, and then what is the filter? And it really depends on the organization that you're working at. Now, it could be in the cases of, let's just call this the FANG companies, right? Is that people, those companies, let's just say a typical salary range would be 150 salary and then 250K in RSUs. So this isn't like funny money like it is in a startup. This is real money, right? So this is actual money you will get. So just if you were able to survive and live a comfortable life on 150 somewhere, maybe hopefully not the Bay Area, which that's actually not a lot of money in the Bay Area, that you could in 4 years you get $1 million. So obviously, plus your whatever it costs for you to survive and pay your mortgage and things like this. So a lot of competition is going for these jobs where you become an instant millionaire. So what they're doing is they're creating like a huge barrier for people to get these jobs by asking them questions that have nothing to do with their job, right? So I don't know why people do this, but they're asking people to do things that are computer science algorithms. And the thought process is that they can't think of a better way to filter, so they might as well just do this, right? In my opinion, it has almost no correlation with DevOps. They're not even related. What are the actual skills you need with DevOps would be that you should know some Python skills. You should know cloud computing, which we're going to get into some of this in a bit. I would recommend getting a certification, and then so I would say certification on whatever cloud platform. And then also you should know about DevOps itself, right? Which is really, DevOps is things like how to build a microservice, and then also how to do continuous delivery, continuous integration. So really, if an organization actually wants you to do DevOps, then they're not going to be asking you computer science algorithm questions, because it has nothing to do with DevOps. There's nothing in DevOps that is algorithms. So I think the real issue is that if you want to work at a company that pays you over 4 years $1 million bonus, then you have to realize that there's a game that you're playing that has nothing to do with what you're actually doing. I know many people that have these jobs, and they told me exactly these same things. Is it's just a game you're playing that has nothing to do with what you actually do at your work, and somebody came up with it. Nobody knows why, but you have to do it. If you work at a company where they actually want you to do DevOps, then these are the skills that you would have to have for DevOps. Okay, so I see, so like a cart dictionary is more suitable design for large amounts of data than a small amount, but I can use lists for small amounts of data as well. Wouldn't a grocery store itself that holds all the products and organisms be comparable to a dictionary? Yeah, I mean, there's lots of different scenarios where you could, there's infinite amount of ideas that we could have around the analogies. And if one works good for you, I would say there's no hard and fast rule, but that sounds like an interesting one as well. Okay, so another question here is, looking for speed in data access, we use MySQL and and Microsoft SQL. Yeah, I think if one of the things that someone brings up here as well is that that things like the MySQL, for example, or I've used both. In fact, on AWS, I've used both, and in other environments, SQL Server. Is that why would you use these things? Is they're trusted, right? These are trusted tools. They've been around for decades, and so why not? They're pretty good performance. And so if your problem fits into a well-tested tool, especially if it's in a cloud environment, like Amazon has something called RDS, where it's a managed service. These are great solutions for dealing with many problems in an organization. Okay, why not JavaScript? Yeah, I think people use JavaScript. There's nothing wrong with JavaScript. I think the core problem that JavaScript seems to solve well is client side, and I think when there are problems that are really inherently client side, that JavaScript can obviously do really amazing things. Like Node. Okay, another question here is Python used much where real-time work is necessary? Also, is Python a detriment since it has to be compiled, or is it not preferred due to security reasons if it can be decompiled? So the other question here is about basically, so Python, I'll just put these out here. So we have one question is, can you use it in real time? So if you're using it where there's an existing system that does all of the work. So let's just take Amazon, right? If we say Amazon itself, you could absolutely build a real-time system on Amazon, because you just use something where Amazon does all the heavy lifting. In fact, here's a perfect example of real time. You could do SQS, which is an infinite queue system. Like literally, you can't break it. You can't send it to enough traffic. And SQS can have a event trigger where it actually calls an AWS Lambda function. And AWS Lambda itself is building up on containerized technology. So with this would be quote unquote real time, right? This is as soon as something populates inside of your system, you could have millions of messages populate from SQS to Lambda. But the great thing about this is you didn't write any of that infrastructure code. You're just using the hardcore infrastructure. So that's my recommendation, would be to use systems that do scale in real time, but use Python as a glue for that. The second one is Python a detriment since it has to be compiled? So Python is a scripting language, so it's not compiled. And also, so it's not compiled. And then also with Python, people could obviously look at your source code because it's a script. But most of the time, people are putting the source code up into the cloud, and so it doesn't matter, right? Because your code is in some other environment and it's being exposed via an API endpoint. Okay. Next question here is, do you have any suggestions on which Python certifications are industry standard or recognized? So for certifications, what I say would be that that in terms of like the Python itself, that it's less likely that you're going to get an industry standard certification for Python. So what I would say for Python would be potentially either like a MOOC somewhere, like something like Coursera would be a good one, or Udacity or Skillsoft or whatever organization has these things. I think those are a pretty good choice. Those are really the kind of places where people are getting certifications. But you also can kind of indirectly get a certification from Python because you can get it from a cloud provider. So for example, AWS has AWS developer certification. And what's nice about that is that with AWS developer, that's essentially Python on AWS. That's what AWS developer certification is. I think there's a lot of value in getting a cloud-based one, or Google. There's also Google Architects, and there's Google Data Engineer, and those are more of like an indirect certification, but they're kind of a double win in that you're basically saying that you know how to program in Python, plus you're able to get very high salaries. I think a lot of AWS certifications are 150 plus that the median is for one of those. So I would say maybe a portfolio of work plus one of these industry cloud certifications that has to do with development is probably the way to go. Although you could also mix it in with a certification from some kind of MOOC provider that has one. Okay, so how to update skills to the current industry and where does Python fit in? We're told to use PowerShell as we're a Windows shop. So in terms of like a Windows shop, I've actually got a reasonable amount of experience with both Windows and Python and kind of the intersection. So let's say you're like a Windows shop for Python, how would you keep leveling up? So the good news is that, I mean, there's no reason PowerShell, sure, you can use PowerShell. There's nothing wrong with PowerShell. But notice that that you can use PowerShell and you can use Python, right? There's no reason you can't use both. And if there's some things that PowerShell does great, like, so we'll say check, you use them both. But it's important to be aware of that Azure itself, which is, that's literally a product from Microsoft, that it is very Python centric now. And in fact, in particular with Azure, they have a product called ML Studio, and ML Studio is essentially all Python, right? And so, I think that's one thing that you could focus on. Also, things like Azure App Services, that Azure App Services can easily deploy microservices in Python. And so it's less likely that someone would be building like PowerShell-based microservices, because that's really not the sweet spot for PowerShell. So I think I would tell your organization that, look, there's a couple places in Azure that are really friendly to Python, including ML Studio for doing ML ops, and also for Azure App Services, which are platform as a service. And so it's good to have a mixture of both Python and and potentially PowerShell. So that's what I would focus on, is stay with what you know and go to ML Studio and Azure App Services. Okay. I sent. So another question, as I meant, compiled to an executable. Okay, so great. I think I was able to answer the majority of questions here. And so what we can do is kind of just keep the ball rolling, so that next session we have tomorrow, we can get into really the practical kind of DevOps stuff. So let me just keep going here and get into the second half of what I wanted to cover today. So we basically got through some of the basics here, and I think the only other thing that's really important for us to really wrap our heads around today is the concept of a function. So let me just also briefly whiteboard this up here. Is that, why do we care about a function in Python? What's the point? So I would say we'll call this maybe level one, is that you understand statements and you understand lists and dictionaries, right? And really, this is good enough for most of DevOps. Is good enough. Level two would be that you're able to use functions in Python. And why do you care about a function? Let's just say this is a function in Python. It's because in Python, you can actually build out many different solutions. It's like the hub, and these are the wheel right here of Python. So what can we do? Well, we can build command line tools, which we'll get into tomorrow. You can build web services, microservices with just a function. You can build parallel code with it very easily. You can do GPU programming. You can do decorators. You can use data science code with pandas. So there's pretty much everything fun you can build out with a function, and it's really an appropriate level of abstraction. And really, a function is just this. It's an input where I have something like this. I have an X and a Y. I do something to it, like let's say results is equal to X plus Y, and then I return back the result. And so this is really the beauty of a function, is that it's very simple. You have a unit of work, you put something into the unit of work, you do something, and then you return it back out. And that's like many things in the world. They're very functional oriented, and that's why functions are probably the best way to kind of level yourself up with Python. And I would recommend basically staying there, right? Is that a lot of the other parts of Python really are not necessary beyond a function for DevOps. So let's go ahead and get into writing a function here. So you can see here, this is the simplest possible function you can write. And so in this case, we have a function that returns back a string. If I print this out, this is really the equivalent of a variable, right? So it's like, does that really get us anything? Not really. And you could even make a more silly function as well by going through here and making a pass statement. And if I print this out, you can see that it returns nothing. So you can make functions that do nothing. I don't know why you would, but you can make them, so simple they don't do anything. If you're documenting a function, a good thing to be aware of is that you can put this triple string here that we talked about earlier, and this is called a doc string, and it can be useful in that it's a way of actually documenting what your function does. And notice that, and we talked about this earlier, that anytime you see these unders, that it's something kind of internal to Python. Well, I can print out that doc string if I want here, and notice that it says this function returns the name of my favorite martial art, right? So it basically goes through here and prints out a doc string for us. And you can also get access to it by doing that trick that I told you before, is if you do the question mark, it'll print out the doc string as well. So it's a neat little thing to be aware of in Python, and it's a great way to document. And even people will do type documentation as well, like what type does this take that is a certain style. So let's go ahead and build out a function here. and start to make this into something useful. So here we go. I can say I like to practice, right? So go here and I say practice, and I take an input called times, and I say, here we go, 2. I like to practice 2 times a day. I like to practice 3 times a day. So what's useful is that even though I wrote this and it's 2 lines of code, I can reuse it in multiple ways. That's really the core reason to use a function versus a variable. If you put something in a variable, or if you put it into a list or a dictionary, it's static, right? Like you've defined it, you can't change it. But with a function, you can change or mutate what happens. And so in this particular example, it was pretty simple. But what if I want to do multiple things? What if I put multiple arguments aside and say, I like to practice the piano 3 times a day for 45 minutes, right? Okay, that's kind of neat. So now I can kind of make it a more reusable function with more powerful things. But what happens if I change the order around accidentally? If I go through here and I say practice, notice it says, I like to practice 7 piano times a day for 60 minutes. Like that doesn't make sense anymore because it's brittle, because it's a positional argument. It's assuming that I'm going to pass in the arguments in the correct order. So a better way to do this would be to use something called keyword arguments. And so keyword arguments are processed by key value and can have default values here. So if we say def practice and I say 2 times technique Python duration 60, notice that it solves 2 problems. 1, now I don't have to worry about the order that I put things into the function. And 2, it has a set of defaults. So if I run this and then I do it again here, notice that I don't have to put anything into the function because it's already got those presets inside of there. And look, if I just change one thing, or 2 things, if I say, I'm going to change the duration to 90 times to 4, I like to practice Python 4 times a day for 90 minutes, then it works out well. So my recommendation would be, if possible, stick with using keyword argument type functions because they're very flexible and less prone to error. Now, you can also do some pretty tricky things with arguments and keyword arguments. Again, these are positional, these are key value, is that if I do asterisk, asterisk keyword args like this, it'll take an infinite number of arguments. So basically, you could just take over and over and over and over again, multiple arguments here. And so in this particular example, look, I put 4 different kinds of attacks, and it says, this is an attack I'd like to practice, this is an attack I'd like to practice. And then I can just put more attacks in there. I can keep on using this over and over again. So that's one kind of useful thing that you can think about, is if you ever needed to kind of handle an infinite amount of arguments, like more than just the keyword arguments that you thought of in advance, you can actually use the syntax to do this. Probably the more safe way to do this, without making a mess, would be you can actually pass in a dictionary itself, and then that will actually be a series of keyword arguments that are packaged together. So if you did want to use this kind of dynamic approach to accepting arguments, putting a dictionary together first is probably the way to go. So let's go to passing around a function next here. What's neat about functions is that if you think of them as like a unit of work, that you can actually pass these units of work around, and you can even tell them to run in the future, or you can tell them to run on demand. And let me actually just sketch this out too. So let me show you in the real world how a function comes into play in probably something you're very familiar with. So here's a house, and a house, a lot of houses have garages, not all of them, but let's just say this is the garage, and you have a garage door right here. This is your house, and notice that most garages have a light bulb inside, and if you think about this light bulb, well, how are you actually able to make that light bulb work? Well, typically there's about 3 methods that the light bulb will work with, and you can think of a light bulb really as a function, right? Or kind of a unit of work. So like, hey, I want to do something with this. So how do I trigger this? Well, one way to invoke it would be that you just turn on the light switch, right? You flip the switch, right? So you flip the switch. That would be a manual invocation of your light switch, right? You just go over, you just turn it on. The second way is that it could actually be triggered, and the light bulb could turn on when the garage door opens, right? And that's what's neat about it, is it's kind of like waiting around. Like the function is just sitting there going, hey, come on, call me, call me. In this case, it's the light bulb. It's like, I want to go on, I want to go on. And then as soon as someone pushes the garage door, boom, it turns on, because it's been invoked by some other system. And then a third way is that a light bulb could go on as a timer, right? And so this is really, a way of thinking about functions, is that they can be invoked many different ways, right? They can be invoked manually, they can be invoked via tying to other things, or they could be invoked in some kind of a timer. And so with Python functions, in fact, this exact concept comes into play with serverless technology, which we'll get into tomorrow. And with serverless, you can actually build systems that think like this. And in fact, the pieces of code they could just be like, 4 lines of code, and it could be as complex as, that light bulb type switch here. So that's really why functions, in my opinion, are really the things that are the most important things to focus on for DevOps, because again, DevOps is about microservices, and serverless is a form of microservice. So if we go back here and we look at this, it's kind of the same concept. Is I have an attack here that accepts a technique. In this case, we can see that if this technique is an attacks, it will return back what it found, or it'll say, I don't know what it is. So if I run this, notice Kimura, it goes through, it looks in its internal dictionary, it says, oh yeah, I know what that is. That's an arm attack, right? And then if I give it a weird attack, like, like professional wrestling or something, it says, okay, bear hug attack. What is that? I don't know what that is. So pretty simple concept, but I can take this logic. This is really the smarts, and I can actually embed that logic inside of another function. And so what I do is I build a function that says, listen, somebody else somewhere wrote a function that knows how to categorize an attack. I don't even know what that is. I don't care, but I'm going to assume that someone will pass in the smarts so that I can tell someone what an attack is. And so here, what I do is I have a list of attacks, and then I go through these lists of attacks, and then I take the function that someone else wrote for me, and then I go through and I say, okay, let's run these multiple attacks. And then basically this thing is using the smarts that I wrote over here. So that also is a really neat concept, is you can make a piece of work that does something and pass that piece of work into another function. Now, where you see this really come into play, and this is a little bit contrived, is something that we're going to cover here, which is closures and functional occurring, which is really like taking this function and just throwing it around to other things and having them do things with it. And so in this particular example, let's look at what this does. So I have a function that's an outer function here that has some state. In this case, this is a counter that keeps track of the state of what's happening inside of here. And then I have a function inside this function. And so this is called functional occurring. And what I do is I set a non-local variable that essentially can only mutate this level of the code. If there was a variable up here, it wouldn't be able to touch it. And so what happens is I do a similar thing, is I keep track of how many times this is called and what attack is actually passed in. And then this will keep a counter for me. So basically, by putting a function inside of a function, I can actually keep track of state, and I have a unit of work that can travel around and independently, have metrics. So maybe this could be like a monitoring system for a game, or like maybe the logic of a video game. So if I go through and I tee this up here, notice that what happens is I return something. What do I return? I don't return something from the outer function. I return the function itself, right? And so if I first tee this up, and I do this, we can see that it actually tees up this function. And then if I look at the type, notice that it's a function that returns a function. And now if I call it and I pass in Kimura, it says upper body attacks 1, lower body attacks 0. So it mutated this variable. If I call it again, it goes through and it says upper body attack 1, lower body 1. So basically, this thing is hanging around, keeping track of the state, because this inner function is tied to this outer function, which has a state that is implicit to its function. It's not global variables that are getting mutated. So it's essentially this atomic unit of work that I can use to keep track of things. And so again, I run it again, and we can see that it's mutated yet again. So this is a pretty cool style that I think shows how functions themselves can really be powerful components that you can throw around. And kind of similar to this is this concept of a partial function. And so here's a partial function where what I do is I say from functools, which is a functional library in Python built in. Notice that it has two different positional arguments. It has attack 1 and attack 2. This is intentionally simple. It does almost nothing. It just prints out the first thing, the second thing. Now notice if I run this, but I put partial in front. So I take the function and I wrap it with a partial, that I can call it with only one variable, but it takes two. How can I do this? Because it's only partially invoked. It's waiting around, just like that other function. It's kind of hanging out, waiting for me to do something with it. And then if I scroll down here and I run it with a second variable, then it fires off. So again, this is a little bit like the example that I showed over here, right? This is kind of hanging around, right? It's like, hey, I'm ready for you to turn me on, but there's different kinds of triggers. So this is a similar concept. This is like a trigger that we're waiting. It's all ready to go. And then someone else will invoke it, and then it'll do the work that we need it to do. And then obviously you can call the function by itself, acts normally. Again, just like the light bulb, you can just turn it on, you can invoke it. So I think that's a very important concept, is to think about functions in the same way you think about a light bulb in your garage. Now, here's another kind of tricky thing that you can do with a function, which I think really explains some other concepts of functional programming. Here's a function that essentially imports random and has a list of attacks here. And what I do is I say, while true, randomly pick an attack. And notice what I do here. I say, while true, yield. If you've used a while true statement in Python, you'll know that while true will basically consume your entire CPU, one core, because it'll just run forever. And you typically don't want to do that unless you're writing like a server or something. In this case, though, what I'm doing is I'm only yielding one thing at a time. It's essentially like a promise. I'm saying, hey, if you call me again, I'll give you another thing, but you need to manually invoke me every single time. So it's kind of like this potential energy or the stored state that I'm invoking here. So if I go ahead and I call this thing, and then I run this next line of code, notice the type that's returned here is a generator. And a generator is a data structure in Python that allows you to deal with infinite structures. And so you can basically infinitely yield in Python these random results. So look, if I call this, I say, look, I want to call this function 6 times, basically. Notice that every single one of these is processed because it runs forever, but it only runs potentially forever because I have to invoke it. If I run it again, it gets another random 6. And so why would you do this? Well, one of the reasons you would use this style is especially with either infinite data or infinite networking, right? So if you needed to sample some data, you may want to use a generator so that it doesn't pull all of it into memory. And if you're dealing with a petabyte of data, you can't just pull in a petabyte of data on most software systems that you're dealing with, unless you're using a big data system. But you could say, I want to connect to an infinite amount of data, but only sample a little bit every time I need to. I'll just randomly kind of sample the data. And so that's one of the really useful things about a generator is its ability to deal with, infinite data, but in a more, logical way that doesn't blow up your system. Now, as I mentioned before, you can do a ton of things with Python functions. And another thing you can do is write decorators. And so decorators are just functions that kind of engulf one function and then mutate them and then return some other result back. So here we go. I think this is a pretty good example of what you can do with a decorator is I write a function that accepts a function. And inside of it, I have a sleep statement here. And then I say return back this function here, and it will wrap again this this other function. And so if I kind of call this and then I put this decorator on top, so you just say at, this will kind of engulf that other function I just wrote, and it will inject inside of here random sleeps. So if I go through here and I run this, and then I do it again, notice that it's now changed the behavior of the function where it's randomly inserting some sleeps inside. So one of the reasons you would maybe want to do something like this would be that you wanted to do chaos engineering, which is a kind of a trendy topic. Like you want to add some kind of variation to a monitoring script, or you want to add debugging code or whatever. But there's a lot of fun use cases for using decorators. If you really want to become an expert on decorators, my recommendation would be that I would use this timing decorator as a place to get started with it. And so what you would do is you'd say from functools, import wraps, from time, import time. And inside of this in particular, if you put in at wraps here, what this does is it preserves the function's name. And so this is just more of something you need to do when you're building a decorator that is doing instrumentation. And all I do here is I make a time variable. I then create an in time, and then I put out a print statement that says, here's the name of my function, here's the arguments it took, here's the keyword arguments I took, and then here's the delta, right? Like of how long everything took. So now if I add this, I can add this to anything. As I just put this on top of something, notice what it does is that it will print out, okay, first the function does its work, and then at the very end, it says, okay, you called a function called sumAttacks, which I did. I passed in bar as again, a positional argument. There were no keyword arguments, and this took 1 second to run. So this is a really fun way to kind of get your head wrapped around functions, is to kind of tweak this and play around with it. And again, you can just play around with it right here at your leisure. Another thing you can do with functions is that you can make classes behave like functions. And one way you could do this is by using this call. So this is more of kind of an artifact to let you know about. And if you go through and you can call it, you can make it kind of act like a function. I don't really find this that useful, but I guess it's just a way to, if you like writing functions and you like writing classes, you can make a function behave like a class by overriding this special method here. And it would basically give you a bunch of state that's kind of waiting around for you. Now, another thing that you can do in with functions here is pandas is a very popular data science library. And in order to do high performance operations on pandas, you would have to write a function and apply it. And I think this is a really good example of how this would work. Is here we can go through here and I can run this code that says import pandas as PD, PD.read CSV. I can look at the shape here, look at this function, and then notice that all it is it's columns here. Here's sepal length, sepal width, petal length, petal width, and species, that it's 150 rows and 5 columns. If I want to do something to this data structure, think of it like a CSV file. What I can do is I can say, I want to operate on just this column called sepal length, which is right here. And I want to round this. I don't want to deal with this anymore. I want this to be rounded. So I could create a new column called rounded sepal length, and I could apply the pandas round function to every single row inside. So if I do this, we can go through here and we see that, yep, it did that. It goes through and it rounded everything up. Now, this is not as easy to understand here because this is a built-in function. So let's go ahead and again, if we look at the shape, you can see I added a sixth column here. But let's write our own function here, which I think is a lot more instructive. If you look at this, this is a really simple function that all it does is that it's a function that takes one thing, which is x, and it multiplies it by 100. And you can take this function and you can do the same thing. You can pass that function to this column. Now, look what happens. If I go through here and I say 100 by sepal length, that look, it does actually multiply it by 100. But you might be going, what is this? I don't really understand. Well, if you want to understand what's happening, take this off. So just print this out. And if you print this out, you'll see what's happening is it's getting called 100 times. So this function, every single, or 150 times, every single observation that's inside of there, every row, this function's applied, but it's done in a very efficient way because of the way the library is written. And so it's a very high performance way to operate on a data frame in Python. So again, a function here is really the secret to building high performance data science operations, because a little bit of code can go a long way. And you could do other things with this and group it and etc. You could build a more complex function as well. That was kind of a simple one, would be a good example. Now, the other thing I'll say here, maybe to kind of end with, is that you can also do something in Python called lambdas, which is not AWS Lambda, but it's an anonymous function. And my advice with this is to be careful about building those, because if you say import this, there's a built-in library in Python called the Zen of Python. And it's just a poem that basically says, if I had to summarize it, it's like, look, keep it simple. And that if we look at a Lambda, you can build these anonymous functions that look really tricky, but they're a little bit kind of hard to read for people, and you can make them really complex, versus this is really easy for most people to read. And the general idea with Python is that you should build solutions that are simple for people to use, and this is much more readable than a Lambda function. So I guess in a nutshell, this is probably a really good spot to maybe kind of wrap things up and tee up, because tomorrow we're going to get into kind of applying all this low-level knowledge to building DevOps solutions. And so maybe this would be a good space as well to take any questions here. So let's see here. What is your recommendation for someone who has database and ETL background to move towards cloud, Python, machine learning? I wonder if old skills can transfer. Yeah, so let's actually answer that thing. That's a great question. In fact, that's a lot of people that I'm teaching actually have similar skills here. It's actually a great skill set. So let's say that you want to transition to from a software engineer, right, to, we'll call this software engineer, to more of ML engineer. I would recommend basically doing what you're keeping the same mindset, of there's a lot of really powerful things that a software engineer has learned. For example, you've probably learned about, DevOps, you've learned about, testing, and kind of software engineering best practices. And I think all of those are missing in a lot of machine learning organizations. And so those are huge benefits. So what are you missing? I would say that the stuff that you would want to kind of focus on would be, I would focus on cloud certification. I think getting some kind of a cloud certification will be really helpful for you. And you could, let's just focus probably on the biggest one. I would say AWS solutions architecture, and then AWS the ML certification. I think those would be great ones to get. In addition, I would build ML applications, and you can actually. I have a really good example. Maybe in the future for Skillsoft, I'll do a whole thing on this. But basically, I have inside of GitHub a practical MLOps cookbook, and I'll put this into our chat here so that everyone can take a look at this. Let's go to here. Let's just throw this into, yeah, here we go. Let's just throw this in there. But basically, if you look at this particular repo, that it's really similar to like a traditional software project. The only thing different is we've got a model, a machine learning model here. And so what I would look at is look at how I built the model, packaged it up, and then was able to containerize it. And then I was able to deploy it to multiple different targets. So really, I think studying this example would be a really good way, plus doing some cloud certifications, and then remembering to use your software engineering best practices. But you can think of machine learning engineering a lot like just another variant of software engineering, and a lot of the data science stuff is becoming automated into higher level tools. So I think it's more that the software engineering is more important than the data science. And I think there's a lot of advantages for people coming from a traditional software background to move into ML engineering, which is very, very lucrative, an emerging field. So yes, you absolutely can transition. Okay, so next question is, in terms of data encapsulation, how would you create a private class with private functions? So that's something in Python that just doesn't exist. And so the question was, in terms of, encapsulation with Python, you just don't do that in terms of OO. It's convention based. So some people in Python will build these double unders, and that's like a convention to like ignore something. But in general, people just don't do that in Python. They don't have that concept of private variables like you do in other languages. Okay, so another question here was, earlier you mentioned Amazon and Azure. Is there one you recommend over the others, beginning with cloud? Yeah, that's a good question. I would say, in terms of which cloud should you pick with, I would use the data science approach, which is, if we say which cloud, if we look at the raw numbers, that it's in order of operations. We've got AWS. That's number one. That's the really the largest cloud provider. Number two is Azure, and then we've got like more of like smaller players here, and there's really a bunch of people tied. It could be, we've got 3 through last would be like Ali Cloud, Google Cloud, all these other clouds. So really either one is pretty good, Azure or AWS. Because this is the largest one right now, I think that they have 40% market share, but I believe that they're the biggest, and then Azure maybe is, I'm just kind of guessing here, but it's something like this, that I would pick AWS just because they're the largest share and they have the largest services. And then I would go through and I would go first with solutions architecture or cloud practitioner certification. And then I would do some specialized certification, either developer or ML or data analytics, one of those. certifications, and I think another good thing to do is build a portfolio. So if you're able to, build a portfolio of your work that shows that you can build solutions on AWS Cloud, and then get the solutions architect, cloud practitioner, and/or one of these other advanced certifications, I think you're in great shape. I mean, really the certifications are very lucrative pathway to kind of get into your next position, and there's a huge demand for this, is people that are certified on AWS technology. Okay, what's the best approach for a network engineer with Python knowledge that can transition to full DevOps? That's a good question. So if you're kind of transitioning to so we'll say like network to DevOps, and we're going to get into this actually tomorrow. So one, I would say show up tomorrow and we'll get into it. But I would say that the biggest thing to be an expert on is CI/CD. And what's nice about CI/CD is that it's pretty straightforward, and the concept, is got some similarities to networking, in that, with a network, it's garbage in is equal to garbage out, right? And so if you have bad data coming into your network, then you'll have bad data coming out. The same thing, with continuous integration and continuous delivery, is that if you're going to automatically deploy your code to production, you need to have something that's kind of a gatekeeper here. So it's, I guess it's similar, in terms of a firewall. Like, this is kind of your firewall for making code, not have problems. And so if you're able to focus on building tests and linting your code and deploying your code automatically, you're invaluable to any organizations. And again, that's exactly what we're going to do. We're going to be very hands-on. I'm going to walk you through tomorrow how to build a continuous integration, continuous delivery process from zero, and kind of build it up. And then I think if you're able to do this and demonstrate it, in my opinion, I've hired lots of people in my life. Anybody that's good at continuous integration, continuous delivery is worth their weight in gold. I think that's the number one skill that I would master. And fortunately, using things like GitHub Actions, for example, it's pretty straightforward to do, and so it's pretty easy to be extremely valuable to an organization. Great question. Any other questions for? We have maybe a couple more minutes here, or now we can actually maybe also I can give it to Chris.
All
I
right.
don't know if
Well,
there's any other questions.